All right, so what we're going to be doing today is laws of motion worksheet. Okay, it's the introduction. This is like an introduction worksheet to laws of motion and getting used to using the formula F equals ma. So let's go ahead and get started here. This is really basic, okay? So I doubt you even need a free body diagram for any of these. So let's go see what's going on here. One, if a car traveling westward with a constant speed of 20 meters per second, what is the resultant force acting on it? Well, right there, you should know that if it's traveling at a constant speed, what is its acceleration? Well, its acceleration is 0, right? So F equals ma. Well, if A equals 0, that whole side equals 0, so the resultant force must equal 0 for it to remain at a constant speed. What that means is, it doesn't mean any forces are acting on it. It means all the forces, once you add them up, come out to 0. In other words, say you're driving down the road, okay? There's friction in the wheel bearings, there's wind resistance, right? So your car has to, when you set your car on cruise control, it keeps the engine on a little bit just to compensate for those forces. That's why the resultant force, because those are, whatever, if you want to set against you to be negative and with you to be positive, those negative forces are zeroed out by the positive force of your engine, keeping you at that constant speed. So the resultant forces need to be 0. 2 says, a passenger sitting in the rear of the bus claims she was injured as the driver slammed on the brakes, causing a suitcase to come flying towards her from the front of the bus. If you were the judge in this case, what disposition would you make and why? Well, we know from Newton's first law, an object in motion tends to stay in motion. Well, if the bus is moving forward and stops, anything in the bus is going to move, is continuing to move that way that the bus is traveling. So she would be incorrect in saying the object came backwards at her. Okay, so an object in motion stays in motion. All right, so she was wrong, and you would say not guilty. Okay. Number 3, a 6-kilogram object undergoes an acceleration of 2 meters per second. What is the magnitude of the resultant force acting on it? If this force is applied to a 4-kilogram object, what acceleration is produced? So we haven't talked about, it does give us an overall force. What's the resultant force? And then it says, if that same force. So we're not talking about individual forces yet. We're looking at overall force. So in that case, we can use, this is number 3, our basic equation of F equals ma. All right? If it's talking about resultant force, or the overall force, or the net force, you just use F equals ma. So it gives us a mass of 6 kilograms. It gives us an acceleration of 2. We need to find what force is required. So I just plug in F equals 6 times 2. I get F equals 12 newtons. All right, we got 12 newtons there. Now what you want to do is it says if the same force, so that 12 newton force is applied to a 4-kilogram object, what is the acceleration? So I still have a force of 12. Now my mass is 4. I'm looking for a new acceleration here. So I use F equals ma. Force is 12. Mass is 4. A is what I'm looking for. I get A equals 3 meters per second squared. Okay? Pretty basic. It's very basic. Okay? A football punter accelerates a football from rest to a speed of 10 meters per second during the time in which his toe is in contact with the ball, about 0.2 seconds. If the football has a mass of 0.5 kilograms, what average force does the punter exert on the ball? So what you're going to notice here is you're getting some one-dimensional motion, equations, all right, or variables. So what you're going to do is let's kind of like list those out, all right. Number 4. We get, let me see what it says. It says from rest, so I know VI is 0. It says to a speed of 10 meters per second, so VF is 10 meters per second. Time is 0.2 seconds. So I'm going to list my force ones over here. So I know mass is 0.5 kilograms. Okay? It says what force. So what average force? I'm going to use a basic equation. Does it make sense that if I know A, I can find force? Well, I have one-dimensional motion. I can find the acceleration the football undergoes while it's in contact with its toe. So I can use this equation here. VF equals VI plus AT. VF is 10. VI is 0, goes away. A is what I'm looking for. T is 0.2. Divide by 0.2. I get A equals 10 divided by 0.2. I get 50 meters per second squared. So again, I can use this. Now I know the acceleration it undergoes. It's 50 meters per second squared. I need to find the force. So go force is equal to 0.5 times 50. Well, half of 50 is 25 newtons. So your foot puts on a 25 Newton force while the football is in contact with the toe. All right? A freight train has a mass of 1.5 times 10 to the 7th kilograms. If the locomotive can exert a constant pull of 7.5 times 10 to the 5th newtons, how long does it take to increase the train from rest to 80 kilometers per hour? So again, you're given one-dimensional motion. The key is, when you're given one-dimensional motion problems, what you need to do is list those one-dimensional motion variables separate from your force variables. All right? So let's go ahead and draw this out. Five. All right? So it has a mass of 1.5 times 10 to the 7th. It has a force of 7. So force is 7.5 times 10 to the, 5th. We know that it starts from rest. VI is 0. VF is, 80 kilometers per hour. We want to know time, how long. All right, so we don't have enough information here. We need another variable. Well, if we found acceleration, we'd be able to solve for t, right? So if I look at this, do I have enough information to solve for a here? Yeah. I have F equals ma. I know F is 7.5 times 10 to the 5th. Mass is 1.5 times 10 to the 7th. A is what I'm looking for. Divided by 1.5 times 10 to the 7th. 1.5 times 10 to the 7th. I get A equals. I do it in my calculator, so a little refresher. 7.5 second EE 5 divided by 1.5 second EE 7. And I get 0.05. So this train accelerates at 0.05 meters per second squared. Alright, so I now know A here. I know A is 0.05 meters per second squared. What you should notice is this is not in base units, so I need to convert. I'll convert very quickly. 1 hour, 3,600 seconds times 1 kilometer, 1,000 meters. Okay? So I go ahead and do that. 80 divided by 3,600 times 1,000 equals 22.2 meters per second. So again, look at my variables. I can use this equation. VF equals VI plus GT, or I'm sorry, AT, same thing. AT. VF is 22.2. VI 0 goes away. A is 0.05. T divided by 0.05. T equals 22.2 divided by 0.05. I get 444 seconds. Okay? Notice that one-dimensional motion doesn't go away. We're using it in this chapter. Okay? So again, you had to be good with that. Number 6. A performer in a circus is fired from a cannon as a human cannonball and leaves the cannon with a speed of 18 meters per second. The performer's mass is 80 kilograms. The cannon barrel is 9.2 meters long. Find the average net force exerted on the performer while he's being accelerated inside the cannon. So again, this gives us one-dimensional motion stuff. So again, I'm going to label one-dimensional motion stuff separate from force stuff. Okay? So let's go ahead and do this. Six. All right, look at this. It says, well, he starts from rest, so I know VI equals 0. I know VF, he gets to 18 meters per second. The mass, so that's force, is over here, 80 kilograms. The length of the barrel is delta X, is 9.2 meters long. I want to know the average force. I need to find force here. I have F equals MA. Well, it should make sense that I need to know A here. So I need to find A using this kind of one-dimensional motion problems here. Look at your equations. What equation are you use? All right, I'm going to use this one. VF squared equals VI squared plus 2A delta X. VF is 18 squared equals VI 0. 2A 9.2. All right, so I can simplify. So I do 18 squared gives me 324 equals 2 times 9.20, 18.4 A. Divide by 18.4. So I do 324 divided by 18.4. I get 17.6 meters per second squared. Okay? So now I can use this. I'll add this to my list over here. I get A equals 17.6 meters per second squared. I plug in F equals M is 80, A is 17.6. The force required is 80 times 17.6. I get 1,408. Okay, so as you can see, the last couple problems were problems that you needed one-dimensional motion or force to find acceleration, so you could use it on the whatever you did use, either one-dimensional motion or force equations. Okay, number 7. Number 7 is the first one that you need a free body diagram for, and it's a very basic one. It already gives you the forces because it gives more than one individual force. This problem is not asking for average force or net force. It's saying all these individual forces are acting on it. You have to do the adding up of them. So it says 7. A boat moves through the water with two forces acting on it. One is a 2,000 Newton forward push by the water on the propeller, and the other is an 1,800 Newton resistive force due to the water around the boat. What is the acceleration of the 1,000 kilogram boat? Okay, so let's go ahead and look at this. Let's draw a picture. It's a basic free body diagram picture. All right. I have the force of the propeller and then the force of the water resisting. One way is positive, one way is negative. So I start with summation of the forces in the x equals MAX. All right. Now remember, this means add up all the forces in the x direction. Well, the only force I have in the x direction is FP is positive minus the force of the water equals. Now you ask yourself, does it have acceleration? Hey, does it have acceleration? Yeah, it's asking you to find the acceleration, so it should have acceleration. So I leave it as MAX. Now I can plug in. The boat has a propeller force of 2,000 minus the water is resisting 1,800. The mass of the boat is 1,000 kilograms. I'm looking for AX. Yeah, is it 1,000? Yeah. All right. So I subtract. I get 200 equals 1,000. AX divided by 1,000. I get AX is equal to 0.2. So I found the acceleration. Now it asks us to do some one-dimensional motion. If it starts from rest, how far will it move in 10 seconds? Well, it says it starts from rest. So VI equals 0. Time is 10 seconds. I know it has an acceleration of 0.2 meters per second squared. I want to know how far will it move, delta x. That means I will use delta x equals VIT plus 1/2 AT squared. Delta x is what I'm looking for. VI is 0, 1/2 A 0.2, T is 10 squared. So I get delta x equals 10 squared is 100 times 0.2 times 0.5. I get 10 meters. It also asks, what will the velocity be at the end of the time? So I can use this. I'm just looking for velocity. I can use VF equals VI plus AT. VI 0 goes away. VF equals A is 0.2. T is 10. I get velocity final is equal to 2 meters per second. All right, these are the basic introduction problems to your force equations and getting used to the, just using force and making sure it's base units and stuff like that. You see how one-dimensional motion and forces link. Acceleration is the linking thing. Forces cause acceleration. All right?